Hello and welcome. I'm truly delighted you're here. Before we get underway, I'd love for you to share in the comments where you're tuning in from and what time it happens to be in your part of the world. It's always such a joy to see this community come together across places and time zones. I also want to take a gentle moment to thank everyone who's subscribed and shown support through likes on the videos. It helps me know what you value most, and it helps others find this space too. Please feel free to leave your ideas for future topics in the comments. Now, let's begin. Chapter 1: Understanding the Atmosphere's Layers. Imagine standing outside on a clear day, feeling the gentle caress of a breeze against your skin. Above you stretches a vast expanse, an intricate blanket that surrounds our planet. This is Earth's atmosphere, a delicate layer composed of gases that not only supports life, but also protects us from the harshness of space. The atmosphere can be divided into distinct layers, each with its own unique characteristics and functions. These layers include the troposphere, stratosphere, mesosphere, thermosphere, and exosphere, each contributing to the grand symphony of life on Earth. Let us begin our journey in the troposphere, the layer closest to the surface, where we live, breathe, and experience the weather. It is within this layer that clouds form, a phenomenon that occurs due to the interplay of temperature and pressure. As warm air rises, it expands and cools, leading to a decrease in temperature. This cooling causes moisture in the air to condense, forming tiny droplets that coalesce into clouds. It's a mesmerizing process that transforms invisible vapor into visible formations, painting the sky with shades of white and gray. Have you ever looked up at a cloud and wondered how it stays afloat? The answer lies in the balance of forces at play. The upward force of buoyancy, caused by the warmer air beneath the cloud, must overcome the weight of the water droplets. This delicate equilibrium allows clouds to drift gracefully across the sky, often signaling changes in weather. As we ascend through the layers of the atmosphere, we encounter the stratosphere, where temperatures begin to rise again. This layer houses the ozone layer, a region rich with ozone molecules that absorb and scatter ultraviolet solar radiation. The interaction between sunlight and atmospheric elements becomes particularly significant here. As sunlight penetrates the atmosphere, it warms the ozone, which in turn protects living organisms on Earth's surface from harmful radiation. Without this natural shield, our planet would be a very different place, struggling to sustain life as we know it. The importance of water vapor in the atmosphere cannot be overstated. It acts as a greenhouse gas, trapping heat and influencing weather patterns. Water vapor is unique. Its concentration fluctuates significantly, ranging from a mere trace to around 4% of the atmosphere's volume, depending on location and weather conditions. This variability plays a crucial role in cloud formation and precipitation. When temperatures rise, more water evaporates, increasing humidity and the potential for cloud formation. Conversely, when temperatures drop, the air can hold less moisture, leading to clearer skies. Imagine for a moment the intricate dance of water vapor in the atmosphere. Picture it rising from oceans, lakes, and rivers, swirling into the air to join the clouds. Each droplet formed is a tiny world, reflecting sunlight and casting shadows on the surface below. As the sun sets, the clouds may turn brilliant shades of orange and pink, showcasing the beauty of this atmospheric phenomenon. The interplay between sunlight and atmospheric elements is not limited to the stratosphere. In the mesosphere, the temperature begins to drop again, where meteors burn brightly upon entry, creating fleeting trails of light. Here, the atmosphere continues to play a critical role, as it serves as a buffer against these celestial visitors. As we move higher into the thermosphere, we encounter a layer where temperatures soar to extraordinary levels, influenced by solar activity. This is a realm of extremes, where the air is thin and the energy from the sun can create dazzling displays of light known as auroras. These colorful lights, often seen in polar regions, are the result of charged particles from the sun interacting with Earth's magnetic field. The exosphere, the outermost layer, gradually fades into space, where the atmosphere becomes almost non-existent. Here, individual gas molecules can travel hundreds of kilometers without colliding with another molecule. This layer is where satellites orbit, playing a crucial part in our modern communication systems. As we explore the layers of the atmosphere, we begin to realize how interconnected these elements are. Each layer, with its unique properties, contributes to the overall health of our planet. The delicate balance of temperature, pressure, and moisture creates the conditions necessary for life to thrive. Reflect on the words of a great scientist who once said, "The Earth is but one country, and mankind its citizens." This sentiment speaks to our collective responsibility to understand and protect the atmosphere that nurtures us. Consider the role of the atmosphere as a life-giving force. It is not merely a backdrop for our existence. It actively shapes our environment and weather patterns. The delicate balance of gases, temperature, and pressure influences everything from the water we drink to the air we breathe. Think about how this knowledge can transform our perspective on the world around us. The atmosphere is alive with activity, a dynamic system that responds to changes in our environment. Understanding its layers and their functions invites us to appreciate the complex interplay of natural processes that sustain life on Earth. As we continue to explore the atmosphere, we will uncover the mysteries of weather phenomena, climate change, and the impact of human activity. Each layer holds secrets waiting to be discovered, and with each revelation, we deepen our connection to the world we inhabit. In this vast atmosphere, the dance of molecules creates a symphony of sounds, colors, and sensations. The whispers of the wind carry stories of distant lands, while the sunlight bathes us in warmth and light. Let us cherish this precious layer of our planet, for it is a reminder of the beauty and complexity of the world we share. The atmosphere is more than just a collection of gases. It is a vital component of our existence, a shield against harsh cosmic forces, and a cradle for life. As we continue our exploration, allow yourself to feel the wonder of this celestial embrace, a reminder of the interconnectedness of all things on Earth. As we delve deeper into the significance of our atmosphere, it is essential to understand the mechanisms behind the formation of clouds. Clouds, those soft, billowing formations that adorn our skies, are not merely decorative, they are integral to our planet's weather systems. When warm air rises, it carries with it moisture from the Earth's surface. Imagine this warm air as a gentle hand, lifting tiny water droplets high into the sky. As the air ascends, it cools, creating an environment where these droplets can condense. The result is a cloud, a collection of countless droplets suspended in the air, each reflecting light in its own unique way. Have you ever noticed how clouds seem to change shape and size throughout the day? This transformation is a direct result of the continuous interplay between temperature and pressure. As temperatures rise, clouds may dissipate, while cooler conditions can lead to the formation of new clouds. This constant cycle of creation and dissolution is a vital aspect of the water cycle, which plays a critical role in regulating Earth's climate. The water vapor within the atmosphere acts as a powerful greenhouse gas, capturing heat and maintaining the delicate balance of temperatures that sustain life. In fact, water vapor is responsible for a significant portion of the greenhouse effect, a natural phenomenon that keeps our planet warm enough to support diverse ecosystems. Without this heat-trapping ability, Earth would be a frigid, inhospitable place, unable to nurture the myriad forms of life we cherish. As we consider the importance of water vapor, let us reflect on its extraordinary role during different weather events. During a storm, for instance, the atmosphere becomes saturated with moisture. When the conditions are right, this excess water vapor condenses rapidly, resulting in heavy rain. Lightning may illuminate the sky, a spectacular display of energy as charged particles collide within the clouds. This interplay of water vapor, temperature, and electrical forces showcases the dynamic nature of our atmosphere. One might wonder how the atmosphere influences our daily lives beyond the weather. The interaction between sunlight and atmospheric elements shapes the very essence of our environment. As sunlight filters through the layers of the atmosphere, it scatters and refracts, creating a spectrum of colors that paint our skies. Imagine a sunrise where the world awakens to soft hues of pink and gold, a gentle reminder of the beauty that accompanies each new day. This scattering of light is due in large part to molecules and small particles in the atmosphere. Rayleigh scattering, for example, is the phenomenon responsible for the blue color of the sky. When sunlight enters the atmosphere, it collides with these tiny particles, causing shorter wavelengths of light, like blue, to scatter more than longer wavelengths, such as red. This interaction is a beautiful example of how the atmosphere transforms our perception of the world. Consider the words of a renowned physicist who once stated, "The beauty of the world lies in the detail." In the context of the atmosphere, this beauty is evident in the intricate patterns created by clouds, the vibrant colors of the sky, and the dynamic weather systems that shape our planet. Each element, from the smallest water droplet to the vast expanse of the atmosphere, contributes to the awe-inspiring tapestry of life. As we explore higher into the atmosphere, we encounter the stratosphere, where the ozone layer resides. This layer acts as a guardian, absorbing ultraviolet radiation from the sun and preventing it from reaching the Earth's surface. Imagine the ozone layer as a protective shield, filtering out harmful rays while allowing the gentle warmth of sunlight to reach us. This delicate balance is vital for our survival, as excessive exposure to ultraviolet radiation can lead to adverse health effects, including skin cancer and cataracts. The importance of the ozone layer cannot be overstated. It not only protects human health, but also plays a crucial role in maintaining the health of ecosystems. Without it, the delicate equilibrium that sustains various species would be disrupted, leading to potential extinctions and loss of biodiversity. As we ascend further into the mesosphere, where temperatures begin to drop again, we witness another astonishing aspect of our atmosphere: the incineration of meteors. When these celestial travelers enter our atmosphere, they collide with air molecules at high speeds. The friction generated causes them to heat up, creating a brilliant display of light as they burn. This phenomenon, often referred to as shooting stars, is a reminder of the dynamic nature of our atmosphere and its role as a protective barrier against space debris. In the thermosphere, we encounter temperatures that can soar to astonishing heights, influenced by solar activity. Here, the atmosphere is thin, and the energy from the sun can create electrifying auroras, those enchanting displays of light that dance across polar skies. Imagine standing beneath these radiant curtains of color, the greens, pinks, and purples swirling together in a mesmerizing performance. These celestial light shows are a testament to the intricate relationship between the sun, Earth's magnetic field, and the atmosphere. Finally, as we reach the exosphere, we encounter a layer where the atmosphere gradually transitions into the vastness of space. Here, gas molecules float freely, with some reaching altitudes where they can escape into the cosmos. This outermost layer is home to satellites that orbit our planet, playing a crucial role in communication, navigation, and weather forecasting. As we traverse these layers, we begin to grasp the delicate interplay of forces that governs our atmosphere. Each stratum contributes to the overall health of our planet, influencing everything from weather patterns to climate change. The atmosphere is a living entity, a dynamic system that responds to both natural phenomena and human activity. In contemplating the atmosphere's layers, we are reminded of the interconnectedness of life. The delicate balance of gases, temperature, and moisture creates an environment where life can flourish. As we continue our exploration, let us hold onto the wonder of this celestial embrace, a reminder of the beauty and complexity of the world we inhabit. Chapter 2: The Process of Condensation Explained. Condensation is a fundamental process that helps to shape the world around us. It occurs when water vapor, in its gaseous state, transforms into liquid water droplets. This transformation is not merely an incidental occurrence. It is a vital part of the water cycle and plays a crucial role in weather patterns and climate. When we think of condensation, we often envision the morning dew that blankets the grass or the fog that envelops a misty morning. But the science of condensation goes much deeper, intertwining with temperature, pressure, and even the presence of microscopic particles in the atmosphere. At its core, condensation is the result of cooling air. When warm air rises, it expands and cools. As the temperature drops, its capacity to hold moisture decreases. This is why you might notice that clouds often form at higher altitudes, where the air is cooler. When the air cannot hold all the moisture it contains, the excess vapor condenses into tiny water droplets. These droplets cluster together, creating the soft, fluffy clouds that drift across the sky. The process is not only a beautiful spectacle, but also a necessary mechanism for precipitation, leading to rain, snow, or hail. Imagine standing beneath a cloud, feeling the coolness of the air that surrounds you. What you may not realize is that the very water that might soon fall as rain was once part of the breath of the earth, a vaporous whisper that floated high above. The transition from vapor to liquid is a dance between temperature and pressure. When air cools to its dew point, the temperature at which water vapor begins to condense, magic happens. The invisible becomes visible, and the cloud begins to take form. The presence of condensation nuclei is also essential in this enchanting process. These tiny particles, which can include dust, pollen, or even salt from the ocean, serve as the foundation upon which water droplets can form. Think of them as the stage on which the performance of condensation unfolds. Without these nuclei, the process of condensation could not occur as efficiently, if at all. Water vapor needs a surface to cling to, and these particles provide just that. As moisture condenses around these nuclei, droplets grow larger and eventually coalesce into clouds. Take a moment to consider how many of these tiny particles surround you at any given moment. They are the unsung heroes of cloud formation, often overlooked yet critical to the processes that shape our weather. When clouds become heavy with water droplets, they reach a point where they can no longer hold the moisture. This leads to precipitation, replenishing rivers, lakes, and the very soil we rely on for sustenance. Across our planet, we can observe numerous examples of condensation in nature. Have you ever seen the delicate dew that forms on leaves in the early morning? This is a direct result of condensation. As the night air cools, moisture in the air condenses on the cooler surfaces of leaves, creating a sparkling display of water droplets that glisten in the dawn light. In colder climates, we witness another form of condensation in the formation of frost. When temperatures drop below freezing, water vapor in the air can condense directly into ice crystals, creating intricate patterns that adorn windows and fields. Each frost flower is a tiny masterpiece, an ephemeral reminder of nature's artistry. In a different realm, condensation plays a pivotal role in the creation of fog. Picture a serene lake at dawn, shrouded in a thick, mysterious mist. This fog forms when warm, moist air moves over cooler waters, causing the water vapor to condense into tiny droplets that hang in the air. The result is a stunning landscape, softened and transformed by the veil of fog, inviting contemplation and calm. As we explore the grandeur of condensation, it is essential to recognize the extraordinary individuals who have dedicated their lives to understanding this process. One such figure is John Dalton, a pioneer in the field of meteorology and the study of gases. Dalton's work on the behavior of gases laid the groundwork for our current understanding of atmospheric processes. He famously stated, "All matter is composed of atoms, and these atoms are in constant motion." This insight into the nature of matter is fundamental to our understanding of how condensation and other atmospheric phenomena occur. Another remarkable individual is Richard Feynman, a Nobel Prize-winning physicist known for his ability to convey complex scientific concepts with simplicity and clarity. Feynman once said, "The beauty of a flower is in its simplicity." This notion can be applied to the process of condensation. While the mechanics may be complex, the outcome, a cloud or a drop of dew, carries a natural beauty that resonates deeply with us. As we journey further into the world of condensation, it becomes clear that this process is not merely a scientific phenomenon, but an integral part of our lives. It shapes our weather, influences our ecosystems, and connects us to the world around us. When we gaze at the sky or feel the cool touch of dew on our skin, we are reminded of the intricate dance of water in its many forms. Additionally, condensation is not limited to the atmosphere. It occurs in our daily lives in various forms. Have you ever opened a cold drink on a warm day and noticed the beads of water forming on the outside of the glass? This is condensation in action. The warm air surrounding the glass cools upon contact with its cold surface, leading to the formation of water droplets. It is a simple yet profound reminder of the intricate processes occurring around us, often unnoticed. In the grand scheme of our planet's climate, condensation plays a critical role in regulating temperature and maintaining the delicate balance of ecosystems. As water vapor rises and cools, it helps to distribute heat around the globe, influencing weather patterns and climatic zones. This distribution is vital for the survival of various species, from the tiniest microorganisms to the largest mammals. Without condensation, life as we know it would be drastically different. As we explore this wondrous process, we can appreciate the interconnectedness of all things. Condensation, while often taken for granted, is a beautiful example of nature's intricate systems at work. It invites us to pause and reflect on the marvels of the world around us. Every droplet of dew, every cloud in the sky, serves as a reminder of the cycles of life, the ebb and flow of water that sustains us all. Imagine for a moment the vast network of clouds, each one a testament to the process of condensation. These clouds, formed from countless tiny droplets, drift across the sky, carrying with them the promise of rain. As they move, they transform the landscape, nourishing the earth and replenishing our water sources. The very act of condensation connects us to the elements, weaving a story of life, growth, and renewal. As we continue to uncover the mysteries of condensation, we are reminded of its significance not just in the atmosphere, but in our everyday experiences. From the gentle morning dew to the clouds that herald a storm, condensation is a phenomenon that surrounds us, waiting to be explored and appreciated. In this exploration, we also recognize the importance of understanding how temperature changes can lead to condensation. The delicate balance of temperature and pressure dictates the behavior of water vapor in the atmosphere. As we delve deeper into this relationship, we find ourselves at the intersection of science and art, where the beauty of nature meets the principles of physics. Thus, we find ourselves on a journey through the enchanting world of condensation, a journey that resonates with the very essence of life. Each moment spent observing this process invites us to marvel at the intricate dance of water in its many forms, reminding us of the beauty and complexity of the world we inhabit. As we delve into how temperature changes lead to condensation, we can imagine the air as a sponge, absorbing moisture in its warm state. When this sponge cools, it loses its capacity to hold all that moisture, leading to the remarkable transformation of vapor into liquid. This intricate relationship between temperature and humidity is fundamental to the formation of clouds and precipitation. Consider the phenomenon of a summer storm. The sun warms the ground, causing the air to rise. This warm air carries with it moisture from lakes, rivers, and the ocean. As the air ascends, it encounters cooler temperatures at higher altitudes. When it reaches a certain point, the temperature drops to the dew point, and condensation occurs. The air, now saturated with water vapor, can no longer hold all the moisture it carries, and clouds begin to form. This process is not just a simple cooling. It is a dynamic interplay that drives weather systems and influences our climate. In this context, we can appreciate the role of condensation nuclei even further. Picture a bustling city on a humid summer day. The air is thick with moisture, but without the tiny particles floating within it, such as smoke, dust, or salt, the process of condensation would struggle to take place. These particles act as miniature seeds, providing a surface for water vapor to condense upon. As water vapor collects around these nuclei, droplets grow, eventually forming clouds that can blanket the sky. The impact of these tiny particles extends beyond mere cloud formation. They can influence the weather patterns we experience daily. For instance, in urban areas, pollution can increase the concentration of condensation nuclei, leading to more cloud formation and potentially altering local weather patterns. Have you ever noticed how cities often experience different weather compared to surrounding rural areas? This phenomenon highlights the intricate balance between human activity and natural processes. As we reflect on the various examples of condensation in nature, we can turn our attention to the breathtaking spectacle of rainbows. When sunlight passes through raindrops, it refracts and reflects within, creating a spectrum of colors that arcs across the sky. This enchanting display is a direct result of condensation. Imagine the joy of witnessing a rainbow emerging after a storm, a moment that captures the beauty of light and water interacting in perfect harmony. Another fascinating manifestation of condensation occurs in the realm of geysers. In places like Yellowstone National Park, underground water heated by geothermal activity rises to the surface. When it encounters cooler air, the steam condenses rapidly, creating spectacular eruptions of water vapor and steam that shoot into the sky. This dramatic display serves as a reminder of the power of nature and the intricate processes at work beneath our feet. Reflecting on these examples, we see that condensation is far more than a scientific principle. It is a beautiful display of nature's artistry, woven into the fabric of our world. From the delicate dew on a spider's web to the grandeur of a thunderstorm, each instance of condensation tells a story of transformation and renewal. As we continue our exploration, we can also consider the role of condensation in the formation of snowflakes. When water vapor condenses in cold air, it can freeze into ice crystals. These crystals grow and combine in the atmosphere, creating the exquisite shapes of snowflakes. Each snowflake is unique, a testament to the intricate conditions present in the atmosphere during its formation. Have you ever caught a snowflake on your tongue or marveled at its intricate design? This beauty arises from the same process that shapes our clouds and rain. In warmer climates, we can witness condensation in the creation of tropical rainforests. These lush ecosystems thrive on the moisture provided by regular rain, which is often the result of condensation processes. The trees and plants release water vapor through transpiration, adding to the humidity in the air. When conditions are right, this moisture condenses to form clouds, leading to the life-giving rains that nourish the forest. As we ponder these connections, we can appreciate how condensation not only influences our weather, but also supports the intricate web of life on Earth. Each drop of water that falls from the sky carries with it the promise of growth and sustenance. Indeed, the process of condensation is a vital thread in the tapestry of nature, linking ecosystems, weather patterns, and human experiences. The remarkable journey of water, from vapor to liquid, from sky to earth, reminds us of the delicate balance of our environment. It invites us to observe the world around us more closely and to appreciate the beauty that exists within the simplest of processes. As we continue to uncover the intricacies of condensation, we find ourselves entwined in a larger narrative, one that reveals the interconnectedness of all life, driven by the rhythms of nature. As we look to the skies, the clouds above us serve as a reminder of this ongoing cycle. Each formation, each shift in the atmosphere, reflects the continuous process of condensation at work, shaping our planet in ways both subtle and grand. What stories do these clouds carry? What experiences do they share as they drift across vast distances? The answers lie in the very fabric of the atmosphere, where temperature, pressure, and tiny particles converge to create the world we see. In the chapters to come, we will continue to explore this fascinating interplay and its implications for our planet. Each droplet of dew, each rainstorm, is a chapter in the ongoing story of condensation, a story that invites us to wonder, to learn, and to remain ever curious about the world around us. Chapter 3: Types of Clouds and Their Characteristics. Above us, the sky is a canvas painted with clouds, a phenomenon that captures our imagination and serves as a vital part of our atmosphere. Each formation tells a story, reflecting the intricate dance of temperature, humidity, and air currents. To understand this celestial artistry, we can begin by exploring the major types of clouds: cirrus, cumulus, stratus, and nimbus. Each type carries its own unique characteristics, revealing insights about the weather patterns we experience. Cirrus clouds, those wispy, feather-like formations, often appear high in the sky. They consist of ice crystals, shimmering like delicate lace against the azure backdrop. These clouds are harbingers of change, signaling that a shift in weather may be on the horizon. As they drift gracefully, they hint at the approach of a warm front, often preceding rain or snow. The sight of cirrus clouds can evoke a sense of anticipation, as if the sky is whispering secrets about what is to come. Imagine standing under a clear blue sky, only to see these ethereal strands start to weave themselves together. The sun's rays catch the ice particles, creating a mesmerizing spectacle. As the temperature dips higher in the troposphere, these clouds form from the moisture that has ascended, cooled, and crystallized. It's a breathtaking transformation, turning invisible humidity into visible beauty. Cumulus clouds, in contrast, are the playful puffs of cotton we often associate with fair weather. They billow and grow, their rounded tops resembling fluffy marshmallows. These clouds form when warm air rises quickly, creating updrafts that cause the moisture within to condense into droplets. As they gather, they can grow into towering structures, sometimes developing into cumulonimbus clouds, which can unleash thunderstorms. The sight of a cumulus cloud can evoke joy, a reminder of sunny days and the simple pleasures of life. Have you ever gazed up at a cumulus cloud and imagined it transforming into something else? As the day progresses and the sun warms the ground, these clouds can evolve dramatically, morphing from innocent shapes into formidable storm clouds. This evolution is a testament to the dynamic nature of our atmosphere, where a tranquil afternoon can shift into a dramatic display of nature's power. As we shift our focus to stratus clouds, a different mood envelops us. These clouds stretch across the sky in uniform layers, casting a gentle, diffused light. They often appear as a gray blanket, signaling the potential for overcast skies and light rain. Stratus clouds form when a layer of cool air is trapped near the surface, and moisture condenses into a thin, uniform layer. Picture a soft fog rolling in, enveloping the landscape in a serene embrace. Stratus clouds remind us of the quieter moments in life, where the world slows down and the air feels soft and still. They often bring a gentle drizzle, nourishing the earth without the intensity of a downpour. This type of cloud can evoke a sense of calm, inviting us to pause and reflect. Then we encounter the formidable nimbus clouds. The word nimbus means rain, and these clouds certainly live up to their name. Dark, thick, and heavy, nimbus clouds are the guardians of precipitation. They form when warm air rises and cools rapidly, leading to significant condensation. The droplets within these clouds grow heavy, resulting in rain or, in colder conditions, snow. Imagine standing outside as a dark blanket of nimbus clouds rolls in, the air becoming charged with anticipation. The atmosphere thickens, and you can almost feel the weight of the moisture. These clouds often herald storms, bringing with them the promise of nourishment for the earth. The sight of nimbus clouds can invoke a sense of awe, reminding us of nature's ability to bring both beauty and intensity. Each type of cloud plays a pivotal role in our understanding of weather patterns. The altitude at which these clouds form can provide valuable information to meteorologists. Cirrus clouds, residing high in the troposphere, often indicate shifting weather, while cumulus clouds may suggest fair conditions, but only for a time. Stratus clouds can signal persistent rain, while nimbus clouds are the bearers of storms. This classification system of clouds is essential in meteorology. By understanding the characteristics of different cloud types, scientists can forecast weather with greater accuracy. Each cloud tells a story, painted by the forces of nature, and learning to read these stories is crucial for predicting the weather. Imagine a scene where a meteorologist stands before a map, tracing the movements of air masses and the formations of clouds. With each cloud type, they piece together a narrative that informs us about what to expect. The ability to decipher these atmospheric cues not only aids in preparation for storms, but also fosters a deeper appreciation for the complexity of our world. Clouds are not merely passive observers in our atmosphere, they are active participants in the water cycle. They form, dissipate, and reform, playing a continuous role in redistributing water across the globe. This cycle is vital for sustaining life, regulating temperatures, and influencing weather patterns. As we explore the skies, we begin to understand the delicate balance that defines our climate. Each cloud type contributes to this balance, influencing everything from local weather to global climate systems. The sight of a sky dotted with various clouds can evoke a sense of wonder, a reminder of the interconnectedness of all things. Consider the words of a visionary in the field of meteorology, who once said that understanding clouds is like understanding the heartbeat of our planet. They pulse and flow, reflecting the ever-changing nature of the atmosphere. This heartbeat is essential, reminding us of the cycles of life, the rhythms of nature, and our place within it. As we look up at the sky, we can appreciate the beauty of clouds not just for their aesthetics, but for their profound impact on our environment. They are both a canvas and a catalyst, shaping the world around us in subtle and dramatic ways. The next time you find yourself gazing at the clouds, take a moment to ponder the stories they hold, the science behind their formation, and the weather they may bring. In this way, clouds become more than mere objects in the sky. They transform into symbols of nature's complexity and beauty. Each formation carries a legacy of knowledge, a testament to the intricate systems that govern our atmosphere. As we continue our journey through the wonders of the sky, let us remain attuned to the lessons these clouds impart, nurturing a deeper connection with the world above us. Cloud types serve as more than mere markers of atmospheric conditions. They are integral to understanding the climate and weather systems that shape our environment. Each formation interacts with solar energy in unique ways, influencing temperature, humidity, and even wind patterns. The altitude at which clouds form can greatly affect their characteristics and the weather that follows. Cirrus clouds, residing high above the ground, often signal that warm air is on the move. As they gracefully stretch across the sky, they can indicate the approach of a warm front, suggesting that a shift in weather is imminent. Imagine the anticipation as the sun's rays illuminate these delicate formations, a precursor to the changes that will soon sweep across the landscape. Cumulus clouds, on the other hand, thrive in the lower troposphere. Their buoyant forms rise in response to warm, moist air, creating a visual delight that often brings smiles to those who gaze upon them. These clouds can develop into towering giants, shifting from soft, puffy shapes to dark, menacing forms as atmospheric conditions change. Picture a scene where a carefree summer day quickly turns, and those once innocent cumulus clouds morph into a thunderstorm, reminding us of the inherent volatility in nature. Stratus clouds, often found at lower altitudes, blanket the sky in a soft, gray hue, creating a serene atmosphere. They can bring gentle rain or drizzle, nourishing the earth in a quieter manner than their tempestuous counterparts. These clouds remind us of the subtle beauty in the world, where even the most unassuming formations play a vital role in the water cycle, contributing to the moisture that sustains life. Nimbus clouds, thick and dark, command attention as they loom overhead, promising rain and often heralding storms. They carry the weight of moisture, ready to release it in droplets that can replenish the ground below. As you stand beneath a sky choked with nimbus clouds, feel the tension in the air, an electric anticipation that signals nature's raw power. These clouds often serve as a reminder of the balance that exists within our ecosystem, where precipitation is essential for growth and life. The altitude of clouds is a fundamental aspect of meteorology, with each type forming at different heights and under varying conditions. Cirrus clouds, found at altitudes above the typical weather patterns, often appear above other clouds, gliding gracefully in the upper troposphere. Cumulus clouds usually form at lower altitudes, while stratus clouds can blanket the mid-level skies. Nimbus clouds, typically associated with stormy weather, can span various altitudes, often extending from lower to higher levels of the atmosphere. Weather patterns tied to these clouds are significant and can change rapidly. For instance, the presence of cirrus clouds may indicate that a warm front is approaching, leading to more humid conditions. Cumulus clouds can herald fair weather, but their evolution into cumulonimbus clouds can signal the onset of thunderstorms. Stratus clouds, when seen in the morning, might suggest a gray, drizzly day ahead, while the looming nimbus clouds could be the harbingers of a heavy downpour. illustrating the dynamic interplay of air masses. Cloud classification is an essential tool in meteorology, allowing scientists to predict weather patterns with increased accuracy. By understanding the characteristics of different cloud types, forecasters can interpret the atmospheric conditions at play. Imagine the meteorologist, standing before their instruments, interpreting the shapes and layers of clouds to predict what weather is on the horizon. Each cloud type serves as a clue, a piece of the puzzle that, when combined, reveals the ever-changing nature of our atmosphere. The importance of cloud classification extends beyond mere observation. It informs agricultural practices, helps in disaster preparedness, and enhances our understanding of climate change. By studying how different cloud types interact with solar radiation and the Earth's surface, scientists can gain insights into the broader impacts of global warming. The relationship between clouds and temperature is intricate, as clouds can both cool the Earth by reflecting sunlight and warm it by trapping heat. Reflect for a moment on the words of an insightful climate scientist who once remarked that clouds are both a symptom and a solution in the climate crisis. They encapsulate the dual nature of our atmosphere, where they can exacerbate warming yet also contribute to cooling through their reflective properties. This duality invites us to consider the broader implications of cloud formation and classification in our quest to understand climate dynamics. As we consider the role of clouds in the water cycle, we realize they are not static. They are part of a continuous flow of moisture that sustains ecosystems and influences weather patterns worldwide. Clouds form, dissipate, and reform, their existence intricately linked to the health of our planet. Each droplet that coalesces within a cloud has traveled through an intricate journey of evaporation, condensation, and precipitation, connecting distant bodies of water to the land. Imagine the journey of a single water molecule as it rises into the atmosphere, becoming part of a cloud, only to eventually fall back to the Earth as rain. This cycle is a vivid reminder of our planet's interconnected systems, where each component plays a crucial role in supporting life. As clouds drift across the sky, they carry with them the stories of distant oceans, lakes, and rivers, weaving a narrative of resilience and renewal. In contemplating the beauty of clouds, we also acknowledge their role in maintaining the delicate balance of our climate. They act as both guardians and messengers, reminding us of the intricate web of life that connects all living things. The next time you find yourself standing beneath a sky filled with clouds, take a moment to appreciate the stories they tell and the vital role they play in our ever-evolving atmosphere. Chapter 4: The Water Cycle, Clouds in Motion. Water, a seemingly simple compound, is the lifeblood of our planet. It exists in various forms, flowing seamlessly through an intricate cycle that sustains life. This cycle, known as the water cycle, encompasses several vital processes: evaporation, condensation, precipitation, and collection. Each step contributes to the continuous movement of water, ensuring that it nurtures and refreshes ecosystems across the globe. Let us first consider the journey of water as it begins its ascent into the atmosphere through evaporation. Picture a serene lake, its surface shimmering under the warm embrace of the sun. As the sunlight kisses the water, energy is transferred, causing the molecules to vibrate and eventually escape into the air as water vapor. This transformation from liquid to gas is not merely a physical change. It is a beautiful reminder of nature's dynamism. Have you ever paused to think about how this invisible vapor, rising from the surface of oceans, lakes, and rivers, is the very essence of the clouds that will soon drift above us? As the water vapor rises, it encounters cooler air at higher altitudes. Here, the temperature drops and the vapor begins to cool, transitioning from gas back to liquid through the process of condensation. This transformation is akin to an artist painting the sky, as tiny droplets coalesce to form clouds. The clouds, in all their varied shapes and sizes, become the vessels of this water, ready to transport it across vast distances. Clouds are not merely fluffy formations, they are crucial players in the water cycle, acting as carriers of moisture. As they journey through the skies, they can travel thousands of miles, driven by winds that weave through the atmosphere. Have you ever watched a cloud slowly drift by and wondered where it came from or where it is going? Each cloud has a story to tell, shaped by the air currents and temperatures it encounters along its path. The role of clouds extends beyond mere transportation. They significantly influence local and global climates. For instance, think of the difference between a cloudy day and a clear one. On cloudy days, the sun's rays are diffused, creating a softer light and often keeping temperatures cooler. In contrast, a clear sky allows sunlight to penetrate more directly, warming the ground and the air above it. This interplay of clouds and sunlight can determine not only daily weather, but also seasonal patterns. As clouds gather moisture, they eventually reach a point of saturation, leading to precipitation. When the droplets within the cloud become too heavy to remain suspended, they fall back to the earth as rain, snow, sleet, or hail, depending on the temperature conditions. Imagine standing outside, feeling the first drops of rain on your skin. This moment marks the return of water to the earth, replenishing rivers, lakes, and soils, nurturing the flora and fauna that depend on it. The cycle continues as water collects in various bodies, seeping into the ground, flowing in rivers, or pooling in lakes. This collection phase is essential as it replenishes groundwater supplies and supports ecosystems. The beauty of this cycle is that it is unending. Water is continually recycled, moving through the various stages of evaporation, condensation, precipitation, and collection. As we explore the impact of clouds on climate further, we find that they are not just passive observers in the sky. They play an active role in regulating temperatures. For example, clouds can act like blankets, trapping heat during the night and keeping the earth warmer than it would be without them. Conversely, they can reflect sunlight during the day, preventing excessive heating. This dual capability highlights the balance that clouds maintain in the climate system. Consider the thought of a world without clouds. What would our climate look like? Without clouds to reflect sunlight and moderate temperatures, we would experience more extreme weather conditions. Some regions might become unbearably hot, while others may suffer from intense cold. Clouds help to maintain a delicate equilibrium, ensuring that our planet remains hospitable to life. Throughout history, many great minds have pondered the mysteries of the water cycle and clouds. Benjamin Franklin, a pioneer in understanding meteorology, once said, "A few hours of sunshine and a few hours of good rain will make a good year." His words echo the sentiment that the harmony of sun and water is vital to the cycles of life. As we reflect on the water cycle, we can appreciate how interconnected all elements of our environment are. The journey of water is emblematic of the larger patterns in nature. Each droplet that falls to the ground has traveled far and wide, playing a part in the intricate web of life. Think for a moment about the clouds that are formed from the very water we drink. This connection between our bodies and the atmosphere is profound. Every drop of rain has a history, and as it nourishes the earth, it also sustains us. The rain that falls in one part of the world may have evaporated from an ocean or lake thousands of miles away, a testament to the interconnectedness of ecosystems. Clouds also influence weather patterns on a larger scale. They are integral to the formation of storms, such as hurricanes and thunderstorms. These powerful systems are driven by the energy released when water vapor condenses into liquid droplets. As the clouds grow more massive and dynamic, they can unleash torrents of rain and fierce winds, reshaping landscapes in a matter of hours. In understanding the water cycle, we cannot overlook the role of human activity. Urbanization, deforestation, and climate change are altering the natural processes that have been in place for millennia. The warming of our planet affects how water evaporates, condenses, and precipitates, resulting in changing weather patterns. Have you noticed how storms seem to be more intense or how droughts have become more common? These shifts can be traced back to alterations in the water cycle, reminding us of our responsibility to protect the delicate balance of our environment. As we continue to examine the beauty and complexity of the water cycle, let us keep in mind the remarkable journey of water, from evaporation to condensation, from clouds to precipitation. Each step is a vital part of a larger whole, embodying the resilience and interconnectedness of life on Earth. The clouds above us, ever in motion, carry with them the promise of renewal and the whispers of an ancient cycle that sustains us all. So, the next time you gaze up at the sky, take a moment to appreciate the clouds, those magnificent carriers of life. Feel the rhythm of the water cycle, in which we are all participants, and let the serenity of this natural process wash over you, reminding you of the delicate balance that sustains our world. As the water vapor ascends and clouds begin to form, we witness the artistry of nature unfold in the sky. Each cloud, whether a delicate cirrus or a sprawling cumulonimbus, tells a unique story about the atmospheric conditions at play. Have you ever considered how these clouds interact with one another? The dynamic relationships among different cloud types can lead to fascinating weather phenomena. When warm, moist air meets cooler air, it can create a symphony of clouds, each vying for space, contributing to the overarching narrative of our atmosphere. When layers of stratus clouds blanket the sky, they can indicate a gentle, persistent rain is on the way. Picture a soft, gray sheet covering the landscape, diffusing sunlight into a gentle glow. These clouds often signal the arrival of a warm front, where warm air rises over cooler air, resulting in steady precipitation. As you watch the rain fall, imagine the cycle of water continuing, flowing from the clouds back to the earth, quenching thirsty plants and nourishing the soil. In contrast, the towering cumulonimbus clouds, with their impressive vertical development, can unleash dramatic storms. These clouds are powerful, indicative of instability in the atmosphere. They serve as a reminder of nature's capacity for both nurturing and destruction. When they gather, they can lead to thunderstorms that rumble and crash, electrifying the air with energy. The intense condensation in these clouds releases heat, further fueling their growth. It is a vivid portrayal of the water cycle in action, where the interplay of temperature and pressure leads to magnificent displays of nature's power. As we delve further into the role of clouds, we realize that they are not only significant in localized weather patterns, but also in shaping global climate systems. The presence of clouds can influence the Earth's energy balance by reflecting sunlight back into space, thus cooling the planet. Conversely, the heat-trapping properties of thick cloud cover can lead to warmer temperatures. Think about this. How does the presence or absence of clouds affect the warm days of summer compared to the cool nights of winter? The subtle dance of light and shadow created by clouds plays a crucial role in regulating temperature across different regions. Clouds also serve as indicators of atmospheric conditions. Meteorologists often rely on cloud formations to predict weather patterns. For instance, the presence of cirrus clouds can suggest that a change in weather is imminent, while stratocumulus clouds might indicate stable conditions. Through careful observation and study, scientists have developed models to understand how cloud behavior correlates with environmental changes, helping us prepare for the unpredictable nature of weather. The extraordinary capacity of clouds to transport water vapor across vast distances cannot be overlooked. Winds carry clouds from one region to another, allowing them to deposit moisture far from their origin. Imagine a cloud that formed over a warm ocean thousands of miles away, drifting across land, releasing its precious cargo to nourish unfamiliar ecosystems. This incredible journey illustrates the interconnectedness of our planet, where the actions in one part of the world can directly influence the vitality of another. Notably, the work of atmospheric scientist John Dalton laid the groundwork for understanding the relationships between humidity, temperature, and cloud formation. His explorations into the properties of gases and their behavior in the atmosphere were pivotal in shaping our current knowledge of weather patterns. Dalton's insights remind us that scientific inquiry is not merely about gathering facts. It is a quest to uncover the intricate workings of the natural world. As we reflect on the significance of clouds in the water cycle, we must also consider the implications of climate change on these vital formations. The warming of our planet affects cloud dynamics, including their formation, distribution, and behavior. Warmer air holds more moisture, leading to changes in precipitation patterns. Some regions may experience heavier rainfall, while others may face prolonged droughts. Have you noticed how the seasons seem to shift, with some areas becoming wetter and others drier? These variations can profoundly impact agriculture, water supply, and ecosystems, making it crucial to understand the changing patterns of clouds in our skies. The relationship between clouds and climate is a subject of ongoing research. Scientists are exploring how clouds interact with climate change and how they can be both a result of and a contributor to global warming. A deeper understanding of these processes could lead to better predictive models, helping us prepare for the challenges posed by a changing climate. Imagine standing in a field, surrounded by the soothing sounds of nature, as clouds gently drift overhead. Each one, a reminder of the intricate processes that sustain life on Earth, carries with it the essence of water, the lifeblood of our planet. The soft hues of a sunset reflecting off the clouds can evoke feelings of peace, yet they also remind us of the responsibility we hold in preserving the delicate balance of our environment. As we contemplate the journey of water through the water cycle, we see that the clouds above are more than mere observers. They are active participants in our climate system. They weave the threads of weather, connecting regions and ecosystems, and nurturing life in myriad forms. The next time you gaze at the sky, let the beauty of the clouds inspire a sense of wonder and responsibility for the intricate web of life that they help sustain. Chapter 5: Mechanisms Behind Precipitation. Imagine standing in a serene landscape, where the air feels alive with the promise of precipitation. The world around you is a canvas painted in shades of gray and blue as clouds gather overhead. Precipitation, in its various forms, plays a critical role in maintaining the delicate balance of our ecosystems. Rain, snow, sleet, and hail, each unique in its structure and formation, tell a story of the atmospheric processes that govern our weather. Rain, often the most familiar form of precipitation, begins its journey as tiny droplets that form within clouds. These droplets cluster together, growing heavier as they collide and coalesce. Picture this: a cloud dense with moisture, its particles suspended in a delicate dance of temperature and pressure. As the droplets become too large to remain aloft, they begin to fall, transforming into the gentle patter of a rain shower that nourishes the earth. Rain can vary in intensity, from a light drizzle to a torrential downpour, influenced by the conditions within the cloud and the surrounding atmosphere. Snow, on the other hand, emerges in a different manner. As temperatures drop, clouds may contain supercooled water droplets, which freeze upon contact with each other or with ice nuclei, forming snowflakes. Each snowflake, a unique crystalline structure, descends softly to the ground, creating a blanket of white that transforms the landscape. Have you ever caught a snowflake on your tongue and marveled at its intricate design? These delicate formations are the result of complex atmospheric dynamics, where temperature and humidity create ideal conditions for ice crystal growth. Then there is sleet, which occurs when raindrops freeze before reaching the ground. This transition from liquid to solid happens when warm air is followed by a layer of cold air, creating a scenario where droplets freeze mid-fall. Imagine the sound of sleet hitting the ground, a gentle tapping that brings a different kind of rhythm to a winter's day. Sleet can create a slick layer on roads and paths, making travel treacherous and reminding us of nature's duality, its beauty and its challenges. Hail, the largest of these precipitation forms during thunderstorms. Within a storm, strong updrafts can carry water droplets high into the colder regions of the atmosphere, where they freeze and grow as they are tossed about. Picture a powerful storm cloud, dark and imposing, where the energy within creates a tumultuous environment. As these frozen droplets descend, they may collide with other droplets, accumulating layers of ice until they can no longer be supported by the updrafts. When hail finally falls, it can be a startling phenomenon, a reminder of nature's raw power. The process of droplet formation in clouds is a fundamental mechanism that connects these various forms of precipitation. As we learned in previous chapters, condensation occurs when warm, moist air rises and cools. This cooling leads to the formation of water droplets, which are the building blocks of clouds. But what happens next is just as fascinating. In the heart of a cloud, droplets can collide and merge, creating larger droplets. This process, known as coalescence, is essential for precipitation to occur. Think about the way raindrops often merge on a window pane, streaking down in a race to the ground. In the sky, this same principle allows droplets to grow until they reach a size that can overcome the forces keeping them afloat. Factors affecting the intensity and duration of precipitation include atmospheric instability, temperature, humidity, and the presence of weather fronts. The rise of warm air can create a powerful updraft, leading to heavy rainfall, while cooler, stable air might result in light, persistent drizzle. Have you ever noticed how a summer storm can unleash a deluge in a matter of moments, while a winter rain might linger, slow and steady? The intensity of precipitation is often dictated by the energy within the atmosphere, revealing how interconnected our weather systems are. Geography plays a crucial role in shaping precipitation patterns. Mountains, for instance, can create rain shadows, where one side of the range receives abundant rainfall while the other remains dry. Imagine standing at the foot of a towering mountain, watching clouds billow against its peak, releasing their moisture on one side while leaving a parched landscape on the opposite end. This phenomenon occurs as air rises over the mountain, cools, and loses moisture, creating lush valleys on one side and arid conditions on the other. Additionally, bodies of water influence local climates and precipitation. Coastal regions often experience higher levels of humidity, leading to increased precipitation. The interaction between land and sea creates a dynamic environment where sea breezes can bring moisture-laden air inland. Have you ever felt the cool breeze off the ocean, carrying with it the scent of salt and the promise of rain? This interaction illustrates how geography and climate intertwine, producing unique weather patterns across the globe. The impact of human activity on precipitation patterns cannot be overlooked. Urbanization, deforestation, and climate change are altering the natural mechanisms behind precipitation. Cities, with their heat islands, can influence local weather, leading to increased rainfall in some areas while exacerbating drought in others. As we continue to reshape our environments, understanding these effects becomes increasingly critical. Imagine a world where the delicate balance of nature is disrupted, leading to shifts in precipitation patterns that affect agriculture, water supply, and ecosystems. As we reflect on the mechanisms behind precipitation, we can appreciate the intricate interplay of atmospheric forces. From the formation of clouds to the myriad forms of precipitation that fall to the earth, every drop tells a story of the environment that surrounds us. It is a reminder of the beauty and complexity of our planet, where each raindrop, snowflake, and piece of hail contributes to the grand narrative of life. The next time you find yourself under a gentle rain or watching snowflakes dance down from the sky, take a moment to consider the science behind these phenomena. Nature's artistry is not merely aesthetic. It is a vital component of the world we inhabit, shaping landscapes and nurturing life in ways both seen and unseen. As we explore the different forms of precipitation, we begin to appreciate the intricate processes that lead to their formation. Each type, rain, snow, sleet, and hail, has its own unique journey, shaped by atmospheric conditions and geographical influences. The process of droplet formation in clouds is essential for understanding why and how these various forms of precipitation develop. Within a cloud, the dance of water vapor begins with condensation. Tiny particles, known as cloud condensation nuclei, provide surfaces for water vapor to cling to, allowing droplets to form. These droplets are so small that they can float suspended in the air, held aloft by gentle updrafts. Have you ever gazed at the sky and wondered how these tiny droplets manage to stay afloat? The answer lies in the balance of forces at play within the cloud. As droplets collide and merge, they grow larger through coalescence. It's a slow and meticulous process, akin to a gathering of friends, each bringing their unique shape and size until they combine into something greater. Eventually, when these droplets reach a critical size, the forces of gravity become too strong for the updrafts to counteract, and they begin to fall. This is the moment when the sky releases its bounty and the gentle rhythm of rain begins. The intensity and duration of precipitation are influenced by several factors. Atmospheric instability plays a key role. When warm air rises rapidly, it can lead to heavy rainfall, while cooler, stable air may result in lighter, prolonged showers. Consider the difference between a summer thunderstorm that unleashes torrents in a short burst and a slow, soaking rain that lingers for hours. This variability showcases the complexity of our atmosphere and how it interacts with temperature, humidity, and pressure. Weather fronts also significantly affect precipitation patterns. When warm, moist air meets cooler air, the warm air rises, cools, and condenses, often leading to precipitation. This interaction is not only fascinating, but also crucial for understanding regional weather. Have you ever noticed how weather forecasts often hinge on the movement of these fronts? They act as the invisible boundaries that can alter our daily lives, bringing sunshine or storms in their wake. The role of geography in shaping precipitation patterns cannot be overstated. Mountains, with their imposing presence, act as barriers to prevailing winds, creating distinct microclimates. As moist air ascends the windward side of a mountain range, it cools and condenses, resulting in heavy rainfall. This phenomenon is known as orographic lift. Imagine standing at the base of a mountain, watching as clouds cling to its peak, releasing moisture in the form of rain. On the leeward side, however, a rain shadow forms, where descending air warms and dries, leading to starkly different conditions. This duality emphasizes how geography intricately weaves together with atmospheric phenomena, creating diverse ecosystems. Coastal areas provide another fascinating example of how geography influences precipitation. The proximity to large bodies of water means that these regions often experience higher humidity levels. Sea breezes can carry moisture-laden air inland, leading to increased precipitation. Have you ever walked along a coastal path, feeling the salty breeze on your face as dark clouds gather on the horizon? This interaction between land and sea highlights the dynamic nature of weather and climate. The impact of human activity on precipitation patterns adds another layer of complexity. Urbanization can create localized weather changes as cities absorb and retain heat, leading to the formation of urban heat islands. This phenomenon can enhance the likelihood of precipitation in urban areas, resulting in rain showers that may not occur in surrounding rural regions. It invites a poignant question. As we continue to build and develop our landscapes, what effects do we have on the natural rhythms of weather? Deforestation also plays a significant role in altering precipitation patterns. Trees act as natural pumps, releasing water vapor into the atmosphere through a process known as transpiration. When forests are cleared, this moisture is lost, leading to reduced rainfall in those areas. Imagine a lush, green forest transformed into a barren landscape. The consequences ripple outward, affecting not only local ecosystems, but also weather patterns far beyond the cleared land. As the climate continues to change, we witness shifts in precipitation patterns globally. The warming atmosphere holds more moisture, leading to increased instances of extreme weather events. Heavy rainfall can result in flooding, while prolonged droughts can emerge in other regions, showcasing the delicate balance that governs our planet's climate. Each drop of rain or flake of snow becomes a reminder of this interconnectivity, a small piece of the larger mosaic of life on Earth. In reflecting upon the mechanisms behind precipitation, we gain a deeper appreciation for the processes that nourish our planet. The next time you find yourself caught in a rain shower or marveling at the beauty of freshly fallen snow, remember that each form of precipitation is a testament to the intricate workings of our atmosphere. It is a reminder that, despite the challenges we face, nature continues to weave its intricate story, sustaining life in ways both profound and beautiful. Chapter 6: The Role of Temperature in Precipitation. Imagine a world where the air is filled with the promise of moisture. Just as the sun warms your skin, the temperature in the atmosphere plays a crucial role in determining the type of precipitation that will fall. This intricate relationship, a delicate balance between warmth and cold, shapes our weather patterns and influences the natural rhythms of life. Temperature determines whether we experience the gentle caress of rain or the soft touch of snowflakes. When warm air rises, it carries with it water vapor, which cools as it ascends. Have you ever wondered why some clouds yield rain while others release snow? The answer lies in the temperature at different altitudes. Above a certain level, if the air remains sufficiently cold, the vapor freezes, forming ice crystals that cluster together to create the snowflakes we adore. Conversely, if the air remains warm enough, those crystals melt before they reach the ground, resulting in the refreshing patter of rain. This phenomenon is influenced profoundly by freezing levels, which serve as a critical threshold in the atmosphere. As warm air rises, it can create a layer of warmth known as a warm front. Imagine this warm front as an inviting embrace, gently pushing against colder air, causing the warm air to rise. The temperature differential creates a dynamic environment where precipitation can occur. If the warm air is sufficiently humid, it can lead to significant rainfall. But when the cold air dominates, snowflakes descend from the sky, transforming the landscape into a winter wonderland. The dynamics of warm and cold fronts further illustrate how temperature affects precipitation. When a cold front advances, it forces the warm air upward more rapidly, leading to the formation of towering cumulonimbus clouds. These clouds are often associated with thunderstorms, showcasing nature's dramatic shifts. As meteorologist Eric Holthaus once said, "Weather is the most complex system we know, and these shifts can lead to sudden and intense precipitation." As you imagine a cold front sweeping in, picture how it alters the landscape. The air feels more crisp, and the sky darkens as clouds gather. This transition brings a sense of anticipation, a reminder of nature's power and unpredictability. The rapid rise of warm air can lead to heavy downpours as it condenses quickly, giving rise to rain that can fall in torrents. Elevation also plays a significant role in how temperature influences precipitation. As you ascend a mountain, the air grows cooler and thinner. In this way, elevation acts as a natural barrier, altering the temperature and moisture content of the air. Picture yourself climbing a steep trail, leaving behind the warm valley below. With each step, the air shifts, becoming brisk and invigorating. At higher elevations, the likelihood of snow increases, especially during the colder months. Mountains are often referred to as climate makers because they can create distinct weather patterns on either side. On the windward side, air rises, cools, and condenses, leading to abundant precipitation. This lush side is often blanketed in greenery, a stark contrast to the arid rain shadow on the leeward side, where the air descends, warming and drying, resulting in significantly less moisture. Have you ever marveled at how one side of a mountain can be vibrant and alive, while the other remains stark and dry? This stark contrast is a testament to the profound impact of temperature and elevation on precipitation. Consider the journey of a raindrop as it falls from the sky. As it makes its descent, it travels through varying temperatures, weaving a story that reflects the atmospheric conditions above. Each drop carries with it the potential to nourish the earth, rejuvenate plants, and fill rivers and lakes. This cycle of precipitation is not just a matter of falling water. It is a tangible connection between temperature, elevation, and the environment. Fascinatingly, temperature also influences the way we perceive precipitation. The soft, delicate snowflakes that drift gently to the ground evoke a sense of tranquility, while the invigorating rush of rain can awaken our senses. As the poet John Keats once expressed, "A thing of beauty is a joy forever." The beauty of precipitation, in all its forms, invites us to pause and appreciate the wonders of our world. In understanding these mechanisms, we can better appreciate the delicate balance that governs our environment. The interplay of temperature and precipitation creates a rich tapestry of weather patterns that influence everything from our daily lives to the ecosystems that thrive around us. As we continue to explore the relationship between temperature and precipitation, consider how these elements shape the landscapes we inhabit. Each drop of rain, each flurry of snow, is a reminder of the intricate processes at play above us. The world is in constant motion, influenced by temperature changes that dictate the very nature of our weather. Reflect on the stories told by the clouds above, each formation a chapter in the ongoing narrative of our atmosphere. Whether it is a gentle rain shower nourishing a parched earth or a heavy snowfall blanketing a quiet landscape, temperature and precipitation are intertwined in a way that underscores the beauty and complexity of our natural world. As we journey through this chapter, let us remain mindful of how temperature shapes the precipitation we experience, reminding us of the delicate balance of nature that sustains life on our planet. Temperature not only determines the form of precipitation, but also influences the intensity and duration of these weather events. When warm air rises and meets cooler air, the differences in temperature can create a significant amount of instability in the atmosphere. Imagine a pot of water heating on the stove. As the temperature rises, bubbles begin to form and rise to the surface. In much the same way, warm, moist air can bubble upward, creating powerful updrafts that contribute to more intense rainfall or snowfall. Consider the role of convection currents, which occur when warm air rises and cooler air sinks in a continuous cycle. These currents can lead to the development of towering clouds, known as cumulonimbus clouds, that can produce heavy rain or thunderstorms. The energy released during this process can lead to phenomena like hail, which forms when strong updrafts carry water droplets into extremely cold areas of the atmosphere. Have you ever witnessed the sudden chaos of a hailstorm, where ice pellets pelt the ground like nature's own percussion? This dramatic event is a reminder of the power of temperature differentials in shaping our weather. Temperature gradients also play a crucial role in determining the overall climate of a region, influencing not just precipitation, but the types of ecosystems that thrive in those areas. For example, tropical regions experience high temperatures year-round, leading to consistent and often heavy rainfall. In contrast, polar regions, characterized by low temperatures, tend to have less precipitation, primarily in the form of snow. This stark difference raises questions about how temperature affects biodiversity. How do organisms adapt to such varying conditions? One remarkable example of adaptation is found in the behavior of migratory birds. Many species rely on specific temperature cues to guide their seasonal movements. As temperatures rise in the spring, these birds embark on journeys toward breeding grounds, synchronizing their life cycle with the peak availability of food. The intricate relationship between temperature and precipitation can thus be seen as a guiding force in the rhythm of life on Earth. The impact of elevation on temperature and precipitation cannot be overstated. As we ascend into mountainous regions, a fascinating transformation occurs. The air cools at a rate that can be quite dramatic, resulting in varied weather patterns over short distances. Picture a lush forest at the base of a mountain, where warmth and moisture create a vibrant ecosystem. As you climb higher, the landscape gradually shifts to alpine meadows, where temperatures drop and precipitation takes on a different character, often becoming more consistent as snow. This phenomenon can be explained through the concept of orographic lift. As moist air encounters a mountain range, it is forced to rise. This uplift cools the air, leading to condensation and precipitation on the windward side of the mountain. What happens, though, as the air descends on the leeward side? The air warms, leading to dry conditions known as a rain shadow. Have you ever wondered why one side of a mountain can be a lush paradise while the other remains parched? This stark contrast highlights the powerful influence of elevation on temperature and precipitation, shaping not just weather patterns, but entire ecosystems. The interplay between temperature, elevation, and precipitation also has significant implications for agriculture. Farmers often rely on predictable patterns of rain and snow to determine planting and harvesting schedules. However, as climate change alters traditional temperature and precipitation patterns, these agricultural practices face new challenges. How can farmers adapt to these shifting conditions? Innovative approaches, such as altering crop varieties or employing precision farming techniques, become essential in navigating this changing landscape. In addition, the relationship between temperature and precipitation extends to our urban environments. Cities, with their concrete structures and asphalt roads, create unique microclimates. The urban heat island effect, where urban areas become significantly warmer than their rural surroundings, can enhance precipitation patterns. Warmer temperatures can lead to increased evaporation, contributing to heavier rainfall events in these areas. Picture a summer storm sweeping across a city, where the combination of heat and humidity creates a torrential downpour, flooding streets and overwhelming drainage systems. This scenario illustrates how urbanization can alter the natural balance of temperature and precipitation, leading to challenges that require thoughtful solutions. As we contemplate the myriad ways temperature influences precipitation, we can appreciate the delicate balance of forces that shape our world. Each rain shower and snowfall is not merely a weather event, but a manifestation of complex interactions within the atmosphere. The stories told by temperature are woven into the very fabric of life on Earth, reflecting a dynamic system that is ever-changing. With each exploration of this intricate relationship, we gain a deeper understanding of our environment. The gentle rhythm of rain or the silent beauty of snowflakes serves as a reminder of the harmony and complexity of nature. As we continue to observe the skies, let's remain curious about the underlying principles that govern our weather, embracing the wonder of the natural world around us. The relationship between temperature and precipitation is not merely a scientific curiosity. It is a vital aspect of our planet's climate system that influences the very fabric of life. Think of how temperature variations can lead to diverse precipitation patterns across different regions, creating a mosaic of climates that support various ecosystems. The interplay of these elements can dictate whether a region is lush and green or arid and barren. In warmer climates, for example, we often witness the phenomenon of convective thunderstorms. These storms arise when the sun heats the ground, causing localized pockets of air to rise rapidly. As this warm, moist air ascends, it cools, leading to condensation and the formation of towering clouds. Have you ever stood beneath the darkening sky, feeling the energy crackle in the air just before a storm? This anticipation is not unfounded, as the process is a vivid reminder of how temperature can stir the atmosphere into action. As we explore these convective systems, we encounter the concept of latent heat, a fascinating aspect of temperature's role in precipitation. When water vapor condenses into liquid droplets, it releases energy in the form of heat. This release of latent heat can further fuel the storm, intensifying its strength and leading to more significant precipitation events. Imagine a pot of soup simmering on the stove. As it heats, the flavors deepen, creating a richer dish. In the same way, the energy released during condensation enriches the storm, allowing it to develop and grow. Conversely, in colder regions, the processes are subtly different. Precipitation often falls as snow, a delicate transformation that depends on the temperature profiles throughout the atmosphere. When temperatures are just below freezing, the conditions are ripe for snowflakes to form and drift gently to the ground. Picture a serene winter day where the world is blanketed in soft, powdery snow, each flake unique and intricate. This beauty is a direct result of the temperature's role in facilitating the delicate crystallization of water vapor. The elevation of a landscape also alters how temperature affects precipitation. In mountainous regions, the temperature gradient can create distinct weather patterns. As moist air rises over a mountain range, it cools, leading to precipitation on the windward side, while the leeward side basks in relative dryness. This phenomenon not only shapes local climates, but also determines the types of flora and fauna that can thrive in these environments. Have you ever thought about how the lush greenery of one side of a mountain can contrast so starkly with the arid terrain of the other? This dramatic interplay illustrates the profound influence of temperature and elevation on our world. The impact of temperature on precipitation extends beyond just the immediate weather patterns. It also influences long-term climate trends and variability. Changes in global temperatures, driven by factors such as greenhouse gas emissions, have far-reaching implications for precipitation patterns around the globe. Areas that once experienced regular rainfall may face drought, while regions that were historically dry might see increased precipitation. This shift raises important questions. How will ecosystems adapt to these changes? What strategies can societies implement to mitigate the impacts of altered weather patterns? The stories of individuals dedicated to understanding these phenomena are equally compelling. Pioneering meteorologists and climatologists have spent their lives unraveling the complexities of our atmosphere. Their insights have led to advancements in weather prediction and climate science, allowing us to prepare for the impacts of temperature changes on precipitation. Each researcher contributes a thread to the larger narrative, helping us comprehend the intricate workings of our planet. As we contemplate the myriad influences of temperature on precipitation, we recognize the interconnectedness of all living things. Every drop of rain or flake of snow carries with it the essence of the atmosphere's temperature and its capacity to nurture life. In this vast and dynamic system, we find a reflection of our existence, an invitation to marvel at the beauty and complexity of nature. Each weather event is not just a momentary occurrence, but a part of a larger story that speaks to the delicate balance of our world. While we observe the clouds that shift and change above us, let us remain attuned to the lessons they offer. The gentle rains that replenish the earth, the majestic snowfalls that blanket the landscape, and the vibrant storms that electrify the sky all remind us of the profound relationship between temperature and precipitation. This understanding deepens our appreciation for the natural world, inviting us to engage with it in thoughtful and meaningful ways. Chapter 7: Weather Systems and Cloud Formation. The atmosphere is a living entity, constantly in motion, shaped by the interplay of forces that create the conditions we experience daily. At the heart of this dynamic system are high and low pressure systems, which act like giant engines driving weather patterns across the globe. When warm air rises, it creates an area of low pressure beneath. This rising air is replaced by cooler air, which descends, forming a high-pressure system. Imagine standing in a field as the gentle breeze shifts around you, with the warm air rising above while cool air replaces it from the side. This movement sets in motion a cascade of reactions, influencing not only temperature and winds, but also the formation of clouds. The interaction between these high and low pressure systems is a dance of energy that shapes our weather. When they converge, they create fronts, boundaries that separate different air masses. A warm front occurs when warm air glides over cooler air, gradually lifting it. Picture the soft, gradual rise of a warm blanket enveloping you on a chilly night. This ascent cools the air, leading to condensation and the formation of clouds. These clouds often stretch over vast distances, creating layers that can blanket the sky in a muted gray, signaling the approach of precipitation. In contrast, a cold front occurs when a cold air mass pushes into a warm air mass, lifting it abruptly. This scenario can lead to the rapid development of towering cumulonimbus clouds, the kind that often herald thunderstorms. Have you ever witnessed the sky darkening dramatically, signaling a storm's approach? This transition is not just a visual spectacle, it is a powerful reminder of the atmospheric forces at play. The collision of these air masses can trigger severe weather phenomena, resulting in heavy rain, hail, and even tornadoes. In the world of meteorology, this is where the excitement and danger intersect. Thunderstorms are remarkable manifestations of nature's power. They begin with the rising warm air, which fuels the creation of clouds. As the air ascends, it cools and the moisture condenses, releasing latent heat. This heat further energizes the rising air, creating updrafts that can reach impressive heights. Imagine a towering column of cloud, reaching toward the heavens as if trying to touch the sky. Within this tumultuous environment, conditions can become ripe for severe weather. The life cycle of a thunderstorm is fascinating. Initially, it starts as a single updraft, forming a cumulus cloud. As the cloud develops, it can grow into a cumulonimbus, the thunderstorm cloud, characterized by its anvil shape. The energy within the cloud can lead to lightning, a dazzling display of nature's electricity. Have you ever felt the thrill of an approaching storm, the air crackling with anticipation? The sound of thunder that follows is the atmosphere's way of announcing its power. As the storm matures, the updraft can become so strong that it creates a supercell, a severe thunderstorm that can produce tornadoes. This phenomenon is both awe-inspiring and terrifying. The rotation of the storm can create a mesocyclone, and if conditions are just right, this rotation can tighten and stretch, forming a tornado that touches down with incredible force. The sheer energy involved in these systems is a testament to the complexity of our atmosphere. The life cycle of weather systems does not end with the storm. After the rain has fallen and the thunder has subsided, the clouds begin to dissipate. This process is just as crucial as their formation. The remnants of moisture in the air may condense into new clouds, or the sun may break through, illuminating the sky in hues of orange and pink as the storm clears. The impact of these weather systems on the landscape is profound. Rain nourishes the earth, replenishing rivers and lakes, while winds shape the terrain. Clouds are not merely passive observers in this grand cycle, they are active participants. The type of clouds that form during these weather events tells a story of their own. After a thunderstorm, the sky may clear to reveal a pristine blue, punctuated by the fluffy white of cumulus clouds, signaling a return to calm. These formations remind us of the delicate balance within the atmosphere, where each storm has its purpose, contributing to the cycle of life on Earth. As we consider the interaction of weather systems, it becomes clear how interconnected everything is. The atmosphere is a vast, swirling ocean of air, where high and low pressure systems collide, creating clouds that reflect the mood of the skies. Each weather event, whether a gentle rain shower or a powerful thunderstorm, is a chapter in the ongoing narrative of our planet. Reflecting on these systems, we can appreciate the beauty in their complexity. They are not just random occurrences, but rather orchestrated movements governed by the laws of physics. The atmospheric pressure, temperature gradients, and moisture content converge to create the weather we experience. Imagine standing beneath a sky filled with clouds, each one a testament to the intricate processes that brought it into existence. The next time you look up, take a moment to marvel at the layers above you, each cloud a whisper of the stories unfolding in the atmosphere. The clouds remind us of the ever-changing nature of our world, where every storm leads to clarity, and every clear day holds the promise of rain. As we delve into these atmospheric phenomena, we see how they shape not only our weather, but also our daily lives. The interplay between high and low pressure, the formation of fronts, and the birth of thunderstorms all contribute to the rich tapestry of our environment. The clouds that float overhead are reflections of these forces, continuously transforming and evolving in response to the energy around them. We become more than mere observers in this intricate system. We are participants in the dance of life, connected to the weather patterns that define our existence. Understanding the mechanisms behind weather systems deepens our appreciation for the world we inhabit. Weather is not simply a forecast. It is a dynamic narrative, unfolding with each passing moment, inviting us to engage with the wonders of the atmosphere. As we explore further, the notion of fronts becomes even more significant in understanding cloud formation. These fronts act as the battlegrounds for air masses, each with distinct characteristics, clashing and intertwining to create a myriad of weather phenomena. When a warm front meets a cold front, the warm, lighter air is pushed upward, leading to the gradual formation of clouds. This rising warm air cools, and moisture condenses, forming layered clouds that often signal prolonged periods of precipitation. Imagine watching a warm front approach, the sky gradually shifting as the clouds thicken. The soft, billowing nature of stratus clouds, which often accompany warm fronts, evokes a feeling of calm, even as they bring the promise of rain. As these clouds spread across the sky, they create an almost ethereal atmosphere, a gentle reminder of nature's ability to transform our surroundings. On the other hand, cold fronts can create a far more dramatic shift. The rapid uplift of warm air forces it into a cooler layer, often resulting in the formation of towering cumulonimbus clouds. These clouds can grow vertically, reaching heights that challenge the boundaries of the troposphere. In this way, the interaction between the two fronts illustrates the raw power of nature. Have you ever felt the sudden drop in temperature that often precedes a storm? This is the unmistakable signature of a cold front, a herald of the tumultuous weather that may follow. Thunderstorms, birthed from these cold fronts, are a vivid manifestation of atmospheric dynamics. The warm air rises with vigor, and as it ascends, it cools rapidly. This rapid cooling leads to the formation of ice crystals and water droplets within the cloud, which can grow heavy enough to fall to the ground as rain. The combination of updrafts and downdrafts within these storms creates an environment ripe for severe weather. The sound of thunder that follows a lightning flash is a reminder of the tremendous energy being released in the atmosphere. Consider the sheer scale of these storms. Some thunderstorms can produce winds that exceed the speed of a racing car, while others may unleash deluges of rain in mere minutes. The intensity of these weather systems varies widely, but each storm has a life cycle that transforms not just the sky, but the very landscape below. The aftermath of a thunderstorm can be just as fascinating. After the fierce winds and pounding rain, the clouds begin to dissipate, revealing the fresh, vibrant colors of the earth below. This transition is a testament to the life cycle of weather systems, which can dramatically alter our surroundings. The moisture left in the air may condense again, leading to the formation of new clouds, perpetuating the cycle of weather. Reflecting on the life cycle of these weather systems, we see that they are not isolated events. Each storm contributes to the intricate web of our climate, influencing ecosystems and weather patterns far beyond its immediate area. The aftermath of rain can nourish the soil, filling rivers and lakes, while also shaping the contours of the land. Throughout history, remarkable individuals have dedicated their lives to studying these phenomena. One such pioneer, an early meteorologist, observed the patterns of storms and recognized the importance of understanding weather systems. His insights paved the way for modern meteorology, helping us to appreciate the forces at play in the atmosphere. This legacy of inquiry continues as scientists strive to decode the complexities of weather. The impact of these weather systems extends beyond immediate effects. As we experience weather events, we are also reminded of the underlying science that governs them. The atmosphere is a delicate balance of temperature, pressure, and humidity, interacting in ways that lead to the creation of clouds and precipitation. Imagine standing in a field after a summer storm, the air heavy with moisture and the scent of rain-soaked earth. The sky may still hold remnants of clouds, their shapes shifting and evolving as they drift away. This moment is a reflection of the ongoing processes of condensation and evaporation that define our weather. As we delve deeper into the mechanics of weather systems, we recognize the profound impact of temperature and pressure on cloud formation. Warm air rising and cooling leads to condensation, and this process is the heartbeat of our weather. The clouds that gather above are not just passive formations. They are active players in the Earth's climate system, impacting everything from local ecosystems to global weather patterns. This understanding invites us to observe the world around us with a renewed sense of wonder. The next time you step outside and look up at the sky, take a moment to appreciate the clouds drifting overhead. Each formation carries with it a story of atmospheric interactions, a testament to the beauty and complexity of our planet's weather systems. As we continue to explore the intricacies of the atmosphere, we find that the life cycle of weather systems is a continuous loop, each phase feeding into the next. The clouds that form, the storms that brew, and the rains that fall are all part of a larger narrative that shapes our world. In this narrative, we are not just observers but participants, intricately connected to the rhythms of nature. The journey of understanding weather systems is one that invites us to engage more deeply with our environment. The interplay of high and low pressure systems, the formation of clouds, and the unfolding of weather events serve as reminders of the dynamic nature of our planet. Each change in the weather is a new chapter in a story that is as old as the Earth itself, urging us to pay attention and marvel at the wonders above us. Chapter 8: The Influence of Climate Change on Clouds. Imagine standing in a field, observing the sky above as it shifts and changes. The clouds, those ever-evolving formations, tell a story, one that has become increasingly complex in the face of climate change. As we embrace the warmth of the sun, we must also acknowledge the subtle yet profound shifts happening in our atmosphere, where rising temperatures are altering the very fabric of cloud formation and precipitation. Climate change, driven by human activity, has begun to reshape weather patterns across the globe. The increase in greenhouse gas emissions traps heat in the atmosphere, leading to a rise in global temperatures. This warming does not simply mean a hotter world. It translates into shifts in the delicate balance of the water cycle, the very cycle that governs how clouds form, how much precipitation falls, and ultimately, how ecosystems thrive. Have you ever considered how these changes might affect the clouds you see overhead? As temperatures climb, the air holds more moisture. This increase in humidity can lead to more extensive cloud cover. Picture the sky filled with thick, billowing clouds laden with moisture. These clouds can produce heavier and more intense rainfall events. The intensity of precipitation, influenced by rising temperatures, can lead to flooding in some areas while drought conditions persist in others. This paradox not only impacts human life, but also affects ecosystems that rely on predictable weather patterns. Ecosystems are intricately tied to the cycles of precipitation. Plants, animals, and entire habitats depend on the rhythm of rainfall, but altered precipitation patterns can disrupt this harmony. When storms become more intense, the soil may not be able to absorb the sudden influx of water. Roots may wash away, and delicate habitats can be destroyed. In contrast, prolonged dry spells can lead to water scarcity, stressing plants and wildlife, which depend on consistent moisture for survival. Consider the story of the Amazon rainforest, often referred to as the lungs of the earth. This vibrant ecosystem relies on a complex interplay of moisture and temperature. When rainfall patterns shift, the results can be dire. Deforestation exacerbates these effects, reducing the forest's ability to produce moisture, leading to a feedback loop of drying conditions. It is a delicate balance that emphasizes the importance of stable precipitation patterns for maintaining healthy ecosystems. As we look to the future, predictions for clouds in a changing climate become increasingly intriguing and concerning. Scientists expect to see changes not only in cloud cover, but also in the types of clouds that form. With warmer air, we may witness a rise in the formation of cumulus clouds, those fluffy, white clouds that symbolize fair weather. However, these clouds can also evolve into towering cumulonimbus clouds, which can lead to severe storms and extreme weather events. Imagine a world where the skies are filled with these towering clouds, signaling powerful storms. The potential for increased storm intensity raises questions about our ability to adapt. Will our infrastructure be able to withstand the heavier rainfalls and stronger winds? How will our agriculture adapt to the shifting patterns of precipitation? These are vital questions that demand attention as we navigate the complexities of a warming world. The influence of climate change on clouds extends beyond mere aesthetics. It touches every aspect of life on Earth. As the climate continues to change, understanding how these shifts will affect weather patterns becomes critical. The intricate dance of air currents, pressure systems, and moisture content will continue to evolve, leading to new dynamics in cloud formation and precipitation. As we reflect on these changes, it is crucial to remember the interconnectedness of our planet's systems. The clouds that drift overhead are not just atmospheric phenomena, they are indicators of broader environmental health. When we see a change in cloud patterns, we should consider the underlying factors at play. What does it mean for our ecosystems, our weather, and ultimately, our future? The journey ahead is filled with uncertainty, but one thing remains clear. Our relationship with the atmosphere is more vital than ever. Understanding the influence of climate change on clouds may help us better prepare for the challenges that lie ahead. The whispers of the winds, the shifting patterns in the sky, and the clouds themselves are all part of a story that is still unfolding. As we continue to explore the influence of climate change, we invite you to imagine the profound beauty of clouds, not just as artistic formations in the sky, but as vital elements of our Earth's climate system. They are both a reflection of and a response to the changes we are experiencing. Let us look up with curiosity and concern, knowing that the clouds above us hold the key to understanding the shifting climate beneath our feet. As we ponder the future of clouds in a changing climate, we can also consider how the distribution of clouds may shift. While warmer temperatures can lead to more moisture in the atmosphere, the geographical locations of cloud formation could alter dramatically. Regions that once enjoyed consistent, gentle rains may find themselves under the shadow of drought, while areas previously characterized by dry climates could become deluged with unexpected storms. This unpredictability creates a ripple effect throughout ecosystems, agriculture, and our daily lives. Imagine the polar regions, where the delicate balance of climate is especially fragile. In these areas, the warming climate is not only melting ice, but is also influencing cloud cover and precipitation patterns. With the reduction of sea ice, there is less reflective surface to bounce back sunlight, further warming the ocean and altering evaporation rates. The clouds that form in these regions may become thicker, trapping more heat, and creating a feedback loop that accelerates warming. The sight of clouds gathering above the shimmering waters of the Arctic, once a sign of balance, now carries the weight of change, evoking feelings of both wonder and concern. As we explore these transformations, we must also consider the remarkable individuals who dedicate their lives to understanding these phenomena. Scientists like John P. Holdren, who served as the director of the White House Office of Science and Technology Policy, have made significant contributions to our understanding of climate systems. His insights remind us of the urgency of addressing climate change. We cannot afford to wait. The costs of inaction are too high. Clouds play a pivotal role in Earth's energy balance, acting as natural reflectors of sunlight. Their ability to reflect solar energy back into space helps to regulate the planet's temperature. As we envision future scenarios, we must ask ourselves, how will the changes in cloud cover influence global temperatures? More clouds could mean a cooler planet in some regions, while in others, they might exacerbate the warming by trapping heat. This duality highlights the complexity of cloud dynamics and their far-reaching implications. The interactions between clouds and climate can also bring about changes in weather extremes. For instance, storms fueled by warmer ocean waters can lead to more intense hurricanes and typhoons, characterized by stronger winds and heavier rainfall. Imagine yourself in a coastal town, watching as the skies darken and clouds swirl ominously above, heralding the approach of a storm that could reshape the landscape and disrupt lives. These extreme weather events not only pose immediate dangers, but also have long-term consequences for infrastructure, ecosystems, and communities. Inland, as we contemplate the effects of altered cloud patterns, consider the implications for agriculture. Farmers depend on seasonal rainfall for their crops, and the unpredictability of weather can lead to significant challenges. A farmer might find their fields flooded one year, only to face drought the next. This inconsistency not only threatens food security, but can also drive economic instability in farming communities. How can we adapt our agricultural practices to accommodate these changes? It is a question that requires creativity and resilience. As we reflect on the broader ecological impacts, we must acknowledge the role of clouds in the carbon cycle. Clouds are not merely passive observers. They actively engage with the Earth's surface and atmosphere. They participate in the transport of carbon dioxide and other greenhouse gases, influencing their concentrations. Picture clouds drifting over a vibrant forest, where trees breathe in carbon dioxide during the day and release oxygen in a symbiotic relationship with their environment. As climate change alters cloud formation, how might these vital exchanges be affected? Looking further into the future, climate models provide tantalizing glimpses into what our skies may look like. Some projections suggest that with continued warming, the frequency of low-lying clouds may decrease, potentially leading to increased solar radiation reaching the surface. This could create a feedback loop, further warming the planet and altering weather patterns. Imagine a sun-soaked landscape, where increased sunlight fuels the growth of deserts, while simultaneously challenging the resilience of once thriving ecosystems. The effects of climate change on clouds are not confined to our immediate environment. They extend globally, affecting weather patterns and ecosystems far beyond our horizons. The interconnectedness of our planet's systems reminds us that no area is immune to the changes we face. As we observe the clouds overhead, we must also consider their implications for distant regions and the global community. As we delve deeper into the influence of climate change, we also encounter the social dimensions of these shifts. Communities around the world are already feeling the impacts of altered weather patterns, and those who are most vulnerable often bear the brunt of these changes. The stories of individuals and communities adapting to new realities serve as reminders of our shared responsibility to protect the climate. How can we foster resilience in the face of uncertainty? The clouds above us are a mirror reflecting the state of our planet, and as they shift and change, so too must our understanding of their role in the climate system. The journey to comprehend the complexities of clouds and their connection to climate change is ongoing, yet filled with hope. The more we learn, the better equipped we become to face the challenges ahead. In this interconnected web of life, the clouds remind us of the beauty and fragility of our planet. They are more than just atmospheric phenomena. They are a vital part of the Earth's climate system, influencing everything from local weather to global temperatures. So, as you gaze up at the sky, consider not only the shapes and colors of the clouds, but also the profound stories they tell about the world we inhabit and the future that awaits us. As we gaze into the future, the implications of climate change on cloud behavior are profound, echoing across every corner of our planet. Clouds may not only shift in their makeup and distribution, but also influence the very fabric of our climate in unforeseen ways. It's essential to consider the feedback loops that arise from these changes. For instance, as cloud cover increases, it can enhance the greenhouse effect, trapping more heat in our atmosphere. Have you ever contemplated how the very clouds that bring life-giving rain might also contribute to warming? The relationship between clouds and climate is a delicate balance, one that scientists are only beginning to unravel. The formation of low-level clouds, often associated with cooling, may diminish in warmer climates. This reduction could allow more sunlight to penetrate, leading to greater surface warming. Conversely, increased high-altitude clouds can act as insulators, maintaining warmth. Imagine the intricate balancing act of these atmospheric guardians, where their presence or absence can tip the scales of temperature and weather patterns. As we consider the future of precipitation, we must also ponder the shift in storm patterns. Historical data suggest that storms are becoming more intense, fueled by warmer ocean temperatures and increased moisture in the air. Picture a once familiar landscape transformed by powerful storms, where once gentle rains now deliver torrents that can reshape rivers and erode shores. This transformation not only impacts human settlements, but also disrupts ecosystems that have thrived for millennia. Communities around the globe are already adapting to these changes. Coastal regions are fortifying their defenses against rising sea levels and storm surges, while farmers are exploring drought-resistant crop varieties. The stories of resilience in the face of climatic uncertainty inspire hope. How can we foster such adaptability in our own lives? It begins with awareness and understanding of the intricate systems at play. The impact of altered cloud dynamics also extends to phenomena such as drought. Regions once characterized by predictable rainfall may find themselves grappling with severe dry spells. Imagine a farmer watching the horizon with a deep sense of concern as clouds that once promised nourishment dissipate into nothingness. This unpredictability can lead to crop failures and food insecurity, creating ripples through economies and communities. As we reflect on these challenges, we must also celebrate the remarkable adaptability of life. Many species have evolved mechanisms to cope with changing weather patterns, adjusting their behaviors and life cycles in response to environmental shifts. Consider the migratory patterns of birds, which may alter their routes and timing based on changing climate conditions. How might these adjustments affect the ecosystems that depend on their presence? The future of clouds in a changing climate is undoubtedly complex. Will we witness a shift in the types of clouds that grace our skies? The potential increase in convective clouds, which can lead to severe weather events, raises questions about the implications for agriculture, infrastructure, and human safety. The very clouds that once seemed benign may become harbingers of chaos under the changing climate. As we navigate this uncertain terrain, scientists continue to refine their models, striving to predict how clouds will respond to an ever-warming world. These predictions are vital, offering glimpses into potential futures based on various scenarios of greenhouse gas emissions and climate action. Each model serves as a reminder of the urgency to act, to mitigate the effects of climate change, and to protect our planet's delicate systems. The clouds above us are not mere decorations in the sky, they are indicators of our planet's health. Each shift in their formation, each change in their behavior, tells a story of our interconnectedness with the environment. As we learn to listen to these stories, we also become more attuned to the pressing need for change. As we continue to observe the skies, let us remain curious about the intricate relationship between clouds and climate. The journey to understanding this connection is ongoing, filled with both challenges and the promise of discovery. With each observation we make, we deepen our appreciation for the complexity of our atmosphere and the vital role it plays in sustaining life on Earth. Chapter 9: Observing and Predicting Clouds. The sky, a canvas of ever-changing hues and textures, beckons the curious to observe and understand the clouds that drift overhead. To do this effectively, we rely on a variety of tools and technologies designed for cloud observation. These instruments range from simple visual aids to complex satellites that orbit our planet, capturing intricate details that our eyes alone cannot perceive. At the forefront of cloud observation is the use of radar technology. Meteorologists employ radar to detect precipitation and analyze the size and movement of cloud formations. This technology sends out radio waves that bounce off raindrops or ice particles, providing valuable information about their location and intensity. Imagine standing beneath a great, dark cloud, while a radar system reveals the hidden details of what lies within. This capability allows us to anticipate storms and understand their potential impact. Additionally, weather balloons filled with helium ascend into the atmosphere, carrying instruments that measure temperature, humidity, and atmospheric pressure at various altitudes. As they rise, they gather data that paints a picture of the atmospheric conditions influencing cloud formation. These observations are crucial for meteorologists as they piece together the puzzle of our weather. Yet, the most transformative advancement in cloud observation comes from satellite imagery. Satellites orbiting Earth provide a comprehensive view of cloud patterns, revealing details that ground-based instruments cannot capture. They offer images that show not just the clouds themselves, but also the larger weather systems at play. When we look at these satellite images, we can see vast swathes of clouds swirling and shifting, providing insight into storm systems that may be brewing miles away. The importance of satellite imagery is profound. It allows meteorologists to monitor cloud development in real time, track the movement of weather systems across continents, and predict changes in weather patterns with remarkable accuracy. Picture a satellite capturing the gradual buildup of a storm, the dense clouds thickening as they march toward a coast. This foresight helps communities prepare for impending weather events, potentially saving lives and resources. Analyzing cloud data is an intricate process, requiring a blend of science and intuition. Meteorologists study both the physical characteristics of clouds and their behavioral patterns to forecast weather. They look for specific cloud formations, such as cumulus clouds, which often indicate fair weather, or nimbostratus clouds, which typically bring steady rain. Each type of cloud tells a story, and experienced meteorologists can interpret these tales. For instance, when cumulus clouds begin to tower, they may develop into cumulonimbus clouds, which herald thunderstorms. This transformation is not just a casual observation, it is a key moment in forecasting. Have you ever wondered how meteorologists know when to issue weather warnings? The answer lies in their ability to analyze patterns. By comparing current observations to historical data, they can identify trends and anomalies. This predictive skill is honed through experience and is vital in providing timely alerts to communities. The art of cloud observation is not limited to professionals alone. Community involvement plays a crucial role in cloud watching and reporting. Amateur meteorologists, often referred to as citizen scientists, contribute valuable observations that enrich the collective understanding of weather patterns. Imagine standing outside on a clear day, looking up at the sky, and noticing the clouds changing shape and color. With a sense of wonder, you might take a photo or note down your observations. This act of engagement is powerful. Citizen reports can help validate satellite data and provide ground-level insight into atmospheric conditions. Communities across the globe have embraced this spirit of observation. Local weather clubs hold cloud identification workshops, teaching participants to recognize different types of clouds and understand their significance. Schools often incorporate cloud observation into science curricula, encouraging young minds to explore the beauty of the sky above. Moreover, social media platforms have become a modern tool for cloud enthusiasts to share their findings. People post images of stunning cloud formations or unusual weather phenomena, creating a vibrant community of observers. This shared passion not only fosters awareness, but also cultivates a sense of connection among individuals who find joy in the beauty of the sky. As we observe clouds together, we begin to appreciate their role in our environment. They are more than just soft, fluffy shapes drifting by. They are indicators of the atmospheric processes that govern our weather. By understanding clouds, whether through advanced technology or simple observation, we deepen our connection to the natural world. The clouds we see today are not merely random formations. They represent a dynamic system influenced by temperature, pressure, and moisture. As we learn more about how to observe and predict these celestial wonders, we unlock a greater understanding of the weather that shapes our daily lives. Through the careful analysis of cloud data, meteorologists can make informed predictions about what lies ahead. This knowledge empowers us to prepare for what nature has in store. The next time you step outside, take a moment to look up at the sky. What clouds do you see? What stories do they tell? Each observation is a step toward understanding the intricate workings of our atmosphere, a reminder of the beauty and complexity that surrounds us. In a world where climate change is increasingly impacting weather patterns, our ability to observe and predict clouds becomes even more critical. The evolving nature of our atmosphere necessitates a response rooted in science and community engagement. By fostering a culture of observation, we not only enhance our understanding, but also cultivate resilience in the face of changing weather conditions. As we stand together, gazing at the clouds, we become part of a larger narrative, one that connects us to the rhythms of the earth. The sky is not just above us, it is a shared experience, inviting us to learn, engage, and participate in the ongoing dialogue of nature. Observing and predicting clouds is not merely a scientific endeavor, it is a celebration of our connection to the planet and the wonders it holds. Meteorologists rely not only on sophisticated technology, but also on a keen understanding of atmospheric science to analyze cloud data effectively. The process begins with the collection of information from various sources, including satellite data, ground observations, and radar measurements. Each of these tools contributes unique insights into the behavior of clouds and their potential impact on weather conditions. Imagine a meteorologist poring over a wealth of data, deciphering the language of the clouds. As they examine satellite images, they look for patterns in cloud formations and movement. This visual information is complemented by numerical weather prediction models that simulate the atmosphere's behavior based on current conditions. These models use equations that describe the physical processes governing atmospheric dynamics, allowing meteorologists to forecast how clouds will develop and move over time. An essential aspect of this analysis involves understanding the thermodynamics of clouds, the interplay between temperature, pressure, and moisture. When warm, moist air rises, it cools and condenses, forming clouds. Observing these transformations can reveal much about the upcoming weather. For instance, when meteorologists notice a rapid increase in cloud cover and a drop in temperature, they might anticipate an approaching storm. The art of interpretation extends beyond the data itself. Meteorologists often draw upon historical weather patterns to make sense of current conditions. By comparing present cloud formations with past events, they can identify trends that suggest similar weather patterns may emerge. This historical context is invaluable. It allows for more accurate predictions, informing communities about potential weather hazards. The importance of satellite imagery cannot be overstated in this context. Satellites equipped with advanced sensors provide a continuous stream of data about cloud cover, temperature, and moisture levels across vast regions. This capability allows for the monitoring of weather systems on a global scale, enabling meteorologists to track storms as they develop and move. Consider the extraordinary ability of satellites to capture images of hurricanes from space. These swirling masses of clouds, with their distinct eye at the center, reveal not only the storm's current state, but also its potential trajectory. By analyzing these images, meteorologists can issue timely warnings to coastal communities, allowing them to prepare for the impending impact. This foresight is a crucial element of modern meteorology, demonstrating the power of technology in safeguarding lives and property. In addition to professional meteorologists, community involvement enriches the landscape of cloud observation and reporting. Citizen scientists play a pivotal role in collecting data that can complement official meteorological efforts. By engaging in cloud watching, individuals contribute their observations to local weather networks, enhancing the collective understanding of atmospheric phenomena. Imagine a group of enthusiasts gathered at a local park, armed with notebooks and cameras, excited to document the clouds above them. Their observations, whether of the serene cirrus formations or the ominous nimbostratus layers, provide valuable ground-level data. This grassroots effort not only fosters a deeper appreciation for the sky, but also bridges the gap between professional meteorology and public engagement. Many communities have embraced technology to facilitate this engagement. Mobile applications allow users to report real-time weather observations, including cloud types and conditions. These contributions can be shared with meteorological organizations, creating a rich tapestry of information that enhances forecasting efforts. This partnership between scientists and the community exemplifies the spirit of collaboration that characterizes modern meteorology. As the saying goes, the best way to predict the future is to create it. By involving individuals in cloud observation, we cultivate a culture of awareness and preparedness. Moreover, educational programs that promote cloud identification and weather literacy empower individuals to better understand their environment. Schools and local organizations frequently host workshops and seminars to teach participants how to recognize different cloud types and interpret their significance. This knowledge not only enhances community resilience, but also inspires the next generation of meteorologists. Through these communal efforts, we forge a connection with the atmosphere that surrounds us. Each cloud observed is a reminder of the intricate processes at work above, shaping our weather and, by extension, our lives. As we become more attuned to these phenomena, we develop a greater appreciation for the natural world and our role within it. The clouds that drift across our skies are not merely ephemeral shapes. They are vital indicators of the atmospheric conditions that govern our daily experiences. By understanding the tools and technologies available for cloud observation, as well as the collaborative spirit that drives community engagement, we deepen our connection to the intricate dance of the weather. As we progress into an era where climate change continues to challenge our understanding of weather patterns, the need for accurate cloud observation and reporting becomes increasingly urgent. The interplay between human activity and atmospheric dynamics is complex, and the more we learn about clouds, the better equipped we are to respond to the changes unfolding around us. Imagine standing in your backyard, observing the clouds shift and evolve. Each formation tells a tale of the atmosphere's mood, a whisper of what is to come. By participating in this observation, whether as an amateur enthusiast or a professional meteorologist, you contribute to a greater narrative, one that connects us to the rhythms of our planet. In this shared journey of discovery, we learn to appreciate not only the beauty of the clouds, but also the science that underpins their existence. Through continued observation and analysis, we cultivate a sense of responsibility towards our environment, recognizing that every cloud is a reminder of the delicate balance we must strive to maintain. Each observation is an invitation to engage with the world above us, to understand its complexities, and to embrace the ever-changing nature of our atmosphere. Chapter 10: The Beauty and Importance of Clouds. Clouds have long captivated the human spirit, serving not only as meteorological phenomena, but also as profound sources of inspiration in art and culture. Artists from various eras have turned their eyes skyward, capturing the transient beauty of clouds on canvas. Consider the works of the Impressionists, who portrayed clouds with sweeping strokes and vibrant colors, conjuring emotions that resonate with viewers. Claude Monet, for instance, often painted the same scene under different cloud formations, revealing how the shifting light and atmosphere can alter our perception of a landscape. Have you ever gazed at a cloud and felt a surge of creativity or nostalgia? The ethereal nature of clouds invites us to reflect, to dream, and to find meaning in their ever-changing forms. In literature, clouds have been woven into the fabric of storytelling, symbolizing everything from fleeting moments of joy to the weight of sadness. The poet John Keats wrote about the clouds of the night as symbols of mystery and beauty. Their presence in our lives is a reminder of nature's artistry, an invitation to pause and appreciate the world we inhabit. Clouds are not merely backdrops. They are characters in the narrative of our existence, shaping our experiences and emotions in subtle yet profound ways. Beyond their aesthetic appeal, clouds serve as vital indicators of weather and climate health. They act as messengers, telling us about the state of the atmosphere above. When we observe cumulus clouds forming on a warm day, we may anticipate fair weather, while dark nimbus clouds signal impending rain. Clouds offer clues that help us understand the complex systems at play in our environment. How do clouds inform us about climate change? As we witness shifting weather patterns, the behavior of clouds becomes increasingly relevant. Scientists study cloud formations and their interactions with climate, recognizing that changes in cloud cover can influence temperature and precipitation patterns globally. The relationship between clouds and climate health is intricate and essential. For example, increased cloud cover can lead to cooling effects on the Earth's surface, as clouds reflect sunlight back into space. Conversely, a decrease in cloud cover can allow for greater solar radiation, contributing to rising temperatures. The balance between these processes is delicate, and understanding how clouds fit into the larger picture is crucial in our efforts to combat climate change. The psychological impact of clouds on human emotions is equally significant. Have you ever felt a sense of calm wash over you while lying on the grass, watching clouds drift lazily by? Research suggests that the presence of clouds can influence mood and well-being. The soft textures and varying colors of clouds can evoke feelings of tranquility and peace. On the other hand, a gray, overcast sky may lead to feelings of melancholy or introspection. This phenomenon is not merely anecdotal. Studies have shown that weather conditions, including cloud cover, can affect our mental health and emotional states. Imagine walking outside on a sunny day, only to find the sky gradually cloaked in clouds. The shift in light and atmosphere can alter your mood, reminding you of the impermanence of nature. The psychology of clouds suggests that our connection to the sky is deep-rooted, influencing how we feel about our surroundings. In a world often filled with chaos, taking a moment to observe the clouds can provide solace, a gentle reminder of the beauty and complexity of life. Encouraging a daily practice of observing and appreciating clouds can foster mindfulness and enhance our connection to the natural world. Take a moment to step outside and gaze upward. What do you see? Is it a brilliant blue sky peppered with fluffy white cumulus clouds or a dramatic expanse of gray stratus clouds? Each cloud carries a story, a history of the air currents, moisture, and temperature that shaped its formation. By observing clouds, we engage with nature, cultivating a sense of gratitude for the beauty that surrounds us. Let your imagination run wild as you look at clouds. Do they resemble animals, faces, or even landscapes? This simple act of observation can spark creativity and inspire a sense of wonder. As you watch the clouds shift and change, consider the role they play in the larger context of our planet. They are not static. Rather, they are dynamic entities that contribute to the water cycle, climate regulation, and ecosystem health. In our fast-paced lives, we often overlook the simple joys that nature provides. Taking a moment to appreciate clouds can serve as a gentle reminder to slow down, breathe, and reconnect with the world around us. By observing clouds, we become attuned to the rhythms of the natural environment, fostering a deeper understanding of our place within it. As we reflect on the beauty and importance of clouds, we find a rich tapestry of meaning woven into their delicate forms. They are symbols of change, indicators of weather, and sources of inspiration that transcend cultures and time. The clouds above us invite us to pause, to appreciate the fleeting moments of beauty in our lives, and to recognize our connection to the earth and the atmosphere that cradles us. Take a deep breath and let the soft imagery of clouds wash over you, reminding you of the delicate balance of nature. Clouds are not just formations in the sky, they are part of a complex system that influences our planet and our emotions. By fostering an appreciation for clouds, we align ourselves with the natural world, opening our hearts and minds to the wonders that lie above. As we gaze at the clouds, let us embrace the beauty in their transient forms, allowing ourselves to be inspired by their artistry and complexity. The sky is a canvas, and clouds are the brushstrokes that paint our experiences, inviting us to explore the connections between ourselves and the world around us. In this shared journey, we find not only beauty, but also a profound sense of belonging to something greater than ourselves. Clouds have woven their way through the artistic expressions of cultures across the globe, appearing in music, poetry, and visual art. The ethereal quality of clouds inspires countless creators to capture their fleeting beauty. Consider the ancient cultures that revered clouds as divine signs, attributing them with significance in their mythologies. In many indigenous traditions, clouds are seen as messengers from the heavens, embodying a sacred connection between the earth and sky. In contemporary art, the interplay of clouds and light is often explored through photography and painting. Artists seek to convey the ephemeral nature of clouds, recognizing how they can evoke memories or feelings that resonate with the human experience. The American photographer Ansel Adams, known for his stunning black and white landscapes, often captured clouds as integral elements of his compositions. His images invite viewers to contemplate the grandeur of nature, offering a moment of stillness amidst the hustle of modern life. As clouds drift across the sky, they serve as indicators of the weather, providing clues about the state of our atmosphere. The wispy cirrus clouds high above may suggest a change in the weather, signaling an approaching front, while the dark, heavy nimbus clouds warn us of impending storms. This ability to read the sky is an ancient skill, honed by generations of people who learned to interpret the signs above them. Understanding clouds can also help us grasp the health of our climate. For instance, scientists have observed changes in cloud cover and types in response to global warming. The warming atmosphere can lead to an increase in cumulus clouds, which can enhance precipitation in some regions while contributing to droughts in others. This duality highlights the complexity of our climate system and the need for ongoing study. How often do we pause to consider the clouds that blanket our skies? They are crucial not only for weather prediction, but also for sustaining life on Earth. Clouds play an essential role in the water cycle, helping to distribute fresh water across our planet. This interconnectedness reminds us of the delicate balance within the environment, urging us to appreciate and protect it. Moreover, the psychological impact of clouds on human emotions is a rich field of study. The mere presence of clouds can influence our feelings and thoughts. For instance, research indicates that people often report feeling more relaxed when they gaze at a clear sky speckled with soft, fluffy clouds. Conversely, a gray, overcast sky may lead to feelings of sadness or nostalgia. In this way, clouds act as mirrors to our inner states, reflecting the ebb and flow of our emotions. As we look up at the clouds, we might ask ourselves, what do these formations evoke in us? Are they reminders of a peaceful afternoon spent outdoors, or do they stir up long-forgotten memories of a summer rain? The answers are often deeply personal, revealing how our experiences shape our perceptions of the natural world. Encouraging ourselves to observe clouds can foster a sense of mindfulness, grounding us in the present moment. Imagine standing outside, taking a deep breath, and allowing your gaze to drift upward. The clouds may morph into fantastical shapes, each moment offering something new to behold. This simple act can create a profound connection to our environment, reminding us of the beauty that exists in the everyday. As we become more aware of our surroundings, we can foster a deeper appreciation for the intricate web of life that sustains us. Observing clouds not only invites us to connect with nature, but also encourages us to reflect on our place within the greater ecosystem. They remind us that we are part of a larger narrative, one that encompasses the rhythm of seasons, weather patterns, and the delicate balance of our planet's health. Each cloud carries a story, influenced by the interplay of temperature, humidity, and air currents. By taking the time to observe and appreciate these formations, we become part of a long tradition of human curiosity and wonder. We engage with nature in a way that is both enriching and calming, allowing ourselves to be enveloped in the soft embrace of the sky. As we cultivate this practice of observation, we may find that our lives become infused with moments of beauty and inspiration. The clouds become not just a part of the backdrop, but an active participant in our daily experiences, offering us the chance to pause, reflect, and connect. In a world that often demands our attention, the simple act of looking up can provide a refreshing perspective, reminding us of the wonders that exist all around us. In the end, clouds are more than mere formations in the sky. They are woven into the very fabric of our lives. They inspire creativity, guide our understanding of weather, and influence our emotional landscapes. The beauty of clouds encourages us to stop and take notice, to appreciate the transient moments that fill our days with wonder. So, the next time you step outside, let your gaze wander upward. Allow yourself to be drawn into the intricate dance of clouds above. What stories do they tell? What feelings do they evoke? Embrace the beauty and importance of clouds and open your heart to the gentle reminders of nature that surround us each day.